You know those absolute value equations? They can look super tricky, right? But what if I told you they're all built on one really simple idea? Today, we're going to break that down and give you a rock-solid method that works every single time. All right, let's start with a little question to get our brains warmed up. What do -4 and +4 have in common? I mean, yeah, they're opposites, but they share something really fundamental. Any guesses? Okay, the answer? It's all about their distance from zero. Both of them are exactly 4 steps away, you could say. And that right there, that's the whole secret to absolute value. It's just distance. And think about it. Can you ever have a negative distance? Nope. So an absolute value can never, ever be negative. Keep that in mind. It's going to be super important later. So let's take that idea and slap it into an equation. If the absolute value of some mystery number, let's call it x, is 4, what could x be? All we're really asking is, hey, what numbers are 4 units away from 0? And just like we saw, there are 2 of them, right? +4 times -4. And that's the key. This is why you so often get 2 answers for these things. All right, that's simple enough. But you know, math problems are rarely that easy. What happens when you see something a little more gnarly, like this one? It looks kind of messy, I get it. But there is one golden rule, just one, that cuts right through all that complexity. And this is it. This is the big one. The most important thing to remember. Before you do anything else, before you even start thinking about what x is, there's one thing you've got to do first. Seriously, if you get this right, the rest is a piece of cake. You have to isolate the absolute value symbol first. Get those bars and whatever's inside them all alone on one side of the equation. That is rule number 1. It is non-negotiable. Don't even think about doing anything else until that's done. So let's put that rule into action with our problem. Our goal is to get that 5x part by itself. What's in the way? That +9. So, simple algebra, right? We just subtract 9 from both sides, and boom! Look at that. All of a sudden, we've got a much friendlier looking equation. See? See why that first step is so critical? Now that we've isolated it, this thing looks just like that first simple problem we did. And from here, we know the drill. This is where we split the problem in 2. Remember, the stuff inside the bars could have been positive or it could have been negative before we took the absolute value. So we have to account for both possibilities. Path number 1, the inside stuff 5x equals the positive result, 10. And path number 2, the inside stuff 5x equals the negative result, -10. And now we just have 2 super easy equations to solve. For the first one, divide by 5, and x equals 2. For the second one, divide by 5, and x equals -2. And just like that, we've got our 2 answers. Done. Okay, so that whole process, isolate, split, solve, it works great. But there's a catch. There's a really common trap that a lot of people fall into. Let's look at another problem and see if we can figure out what it is. All right, check this one out. I mean, it looks pretty much the same, doesn't it? We've got an absolute value, a number added to it. Looks familiar. So let's just use our golden rule and see what happens. Okay, rule number 1, isolate. To get that x minus 3 alone, we've got to get rid of that +3. So let's subtract 3 from both sides. And we're left with this. Now, hold on. Take a really close look at that result. Does anything seem weird to you? Yeah, this is where you need to slam on the brakes. The equation is telling us that an absolute value is equal to a negative number. That should set off alarm bells in your head. A huge red flag. But why? What's the problem? Let's rewind all the way back to the beginning. What did we say absolute value is? It's distance, right? Just a number's distance from 0. And distance has a fundamental rule. You literally can't have negative distance. It just doesn't make sense. I can't be -5 feet away from my desk. So if absolute value is distance, then it is absolutely impossible for it to equal a negative number ever. The absolute lowest an absolute value can be is 0. That's the distance from 0 to 0. It can be positive, it can be 0, but it can never, ever, ever be negative. And that's the big lesson here. If you follow the rules, you isolate the absolute value, and you see it equals a negative number, you stop right there. You don't have to do anything else. The answer is simply no solution,
because there is no number on planet Earth that could possibly make that equation true. So let's recap the whole game plan into a simple 3-step process. First, you isolate. Get those absolute value bars all by themselves. Second, you split. You make your 2 paths, one for the positive answer, one for the negative. And third, you solve. And just remember that critical check after step 1. If you isolate it and it equals a negative, you found the no solution trap, and you can just stop.
So if you take one thing away from all this, what should it be? What's that number one golden rule you've got to remember when you see an absolute value equation? That's right, isolate it first. Always. You do that, and you'll sidestep all the tricky parts and turn any of these problems into something you know exactly how to handle.